a few seconds and we're going to start recording. Okay, so once again, this will be Shaper again to learn on 3D, and I already have a previous video on that, but I would like to show you how to do the cutting operation step by step. What I did use to show that to the students in the advanced manufacturing, and if we have any student here who attended the advanced manufacturing will remember that, I use the Excel sheet to show the thing. So I just brought the same part. As you can see, this page I show you actually here is the University of Western Sydney assignment number 1 for this semester, the previous semester. And you can see that what we need to ask them to do here, we need to have 12mm diameter cutting tool, and we need to draw the freehand sketch. And I'm going to show you how to do the freehand sketch. It doesn't have to be Michelangelo to make the freehand sketch. Just make something simple that you will understand. No, the people need to understand. Define the datum point, because this will be a very important thing, and the tool path, because you will need this tool path to locate the points that the cutting tool center will move between. What we need to do as well is, just give me 1 second. Yep, write the code. Write detailed machining processes planning step. I'm going to leave this one briefly because it's something similar to the what we call the route sheet that we learned on how to do it in the manufacturing engineering. You remember the route sheet when we said what will be the steps? Holding the part, do the step number 1, do the step number 2, 3, 4, take out the part, inspect it, then put it on another machine and do the work. Here, just because I'm trying to make a different task for different students, I use some of the parameters, which are A and the B, and that's something we're going to ignore it in this session because someone want to join or what? Okay. Because it's not a test thing. We just want to make the same code, and you can even share the knowledge between you guys and help each other to understand the process of writing the code. Okay, so you can see that we only can use, well, actually, you can use only these codes to write down the full code for making this part. Now, let's first analyze the shape. Take a look at the shape. What do you think that we can set the datum point of that shape? Center? In the center, yeah, because simply this shape is symmetrical. Well, I know that we have C, but in general, if I'm going to cut this one in the half, I will have the 2 halves going to be the same. And also you can see that again to have multiple circles, so I need to have the center to be the 0, 0 point. So I'm going to select the datum point of that shape to be in the center. Of course, you can have it in the middle here as well, but it doesn't matter as long as we can set that center to be in the middle. As long as you are going to have a circular shape, which is going to have symmetry, so we can have it in the middle. Now, the same thing actually can be done with any other cut, because we said that we don't have a specific location for the datum point. The only reason for having the datum point to be in the lower corner to the left is that because this will be somewhere to be located on the visor holding the part. Because sometimes that the work part itself, when we say the work part, That's mean the piece we're going to start working in doesn't have, they're not going to have the same dimensions. And that's why we always prefer to take it to the corner. So when we're going to remove the material, we're not going to hit the device. However, for this part, we can do the work using the center as the datum point, do the whole work. Then later we can hold it by another way, which is going to be the bolts and the nuts. And then we can do the profile cut for the outside. And then we're going to have the circular shape. Now, let's have a look here and let's try to make the hand sketch for this part. Because once again, I'll tell you that this will be a very necessary step. These are the dimensions of the part shown in this image. Okay, you can see that the circle, it does have the diameter of 195 plus b. B can be any number from 0 to 9. So I'm going to use it as 0. So 195. These small holes are 12 millimeter diameters. We have the circle in the middle, have the diameter of 25 millimeters. I'm going to choose at 25. Now I'm going to do 25 plus b. And we have the center arc of the horseshoe shape here. Going to have the radius of 35 millimeters. The length of the hexagonal shape here, hexagonal, yes, hexagonal shape here is going to be 65 millimeters. So with these dimensions, we're going to start sketch the part first. And then, well, I'm going to only do the sketch because I would like you to understand how to do it. And later we're going to start to put the points like and the lines like what we did earlier. These lines is going to be intersect, and we're going to find the points of the intersection that the cutting tool need to move in between. So let's go to the camera, and we will start to make the shape. Why this camera is a blur? Yep, now it's better. I had the new holder today. So what's happening if I get to right? Ah, it's upside down. Sorry for that. Don't know how it's flipped, but yeah, I'm a mechanical engineer, and that's why I have this panel here at the side, as you can see. Yep. Actually, I was changing my wife signal bulb, and that's why I need this panel. I bought something from Kmart today, and to push these things away, make space for my new holder. Doesn't seem to be as good as the one we had before, but anyway, it will do the job. Okay, so the most important thing is to have a paper. We're going to have the pen, and we're going to sketch the part. So as you remember, we had a hexagonal shape. I will start with the hexagonal shape first. Was it hexagonal or was octa? 1, 2, 3. Yep. 3 and 3 and 6. Yes, right. Okay, so we start with making this shape first. 1, 2, 3. We learned that in school. Okay. 1, 2, 3. So 1, 2, 3. And I'm going to have a line here. Okay, the center is going to be here. This will be my datum point. I think I choose another place. Yep. Okay, so as you can see, for the hand sketch, it doesn't have to be 100% accurate sketch. It's just hand sketch. And then we're going to have inside a circle with a diameter of 25 millimeters. We're going to have the horseshoe. And if you remember that the shape have an angle between the start and the end. And I think that this angle is mentioned somewhere. Ah, yeah, it's mentioned here, 270 degree. So the point from the point starting and the point ending is going to be 270. That means that the distance between that point and that point as an angle distance is going to be 360 minus 270, and this will make it 90 degree. So I'll go back to sketch. So if I again to make it as an accurate thing, I will make the lines, okay? And here is going to be 45, and here is going to be 45, because this will be 90 degree. I'm just making the sketch to show you how we can find out the points. Okay, so we said it's going to be 35. So this one is 25 as a diameter. The radius is 12.5, and we have 35 as a distance. So it's going to be something about 35 minus the 12.5, and this will make it as 23.5. So the distance between the arc of the circumference of the circle and the point we're going to start with is going to be about 23 degree. Same thing is going to be on the other side, and then we're going to sketch the arc with the radius of 35 degree. Now, what we have as well is a big circle with 135 millimeter diameter or radius, I don't remember. And this one has the multiple holes around. I remember that the holes were 1, 2, 3, 6. You can see actually that the hole is going to be located in between the corner of the hexagonal shape and the outer circumference of the circle. So we can locate the location of these points simply by extend. Well, of course, this should be something like that. Okay, so sketch these imaginary lines. And the hole is going to be in the distance between these two locations. So we're going to have the hole number 1, hole number 2, hole number 3, 4, 5, and 6. This should be enough for a handy sketch. Once again, this is just to explain to us where we can find the location of the points, again, to make my work on. So what do you suggest? What will be the first thing we can write down the code for it? So it's not going to be the first operation, because just remember that this part is going to start with a cubical shape. So it's going to be a cube shape with these dimensions. We're going to have a block, and we're going to cut the material to have this final shape out of it. So we start with a square. We need to remove the material around to have the disc shape. We need to remove the material from the top until we're going to have that shape. So we can say that our block is going to be, we need to find once again what will be the diameter here. We're talking about the phi is 195. That's mean, let's say the block is going to be 200 millimeter on the sides, 200 by 200. I think that the engineering drawings also tell us something about the depth of the work part. Yep, the thickness. You can see that the thickness, total thickness, is going to be 15 millimeters. So usually we're going to choose something about 18 millimeter for thickness. If we're going to talk about the standards, we need to go for 20 millimeter diameter thickness plate. So the block we're going to start with is going to be 200 by 200 by 20 millimeter thickness. This will be the block I should start my work with. Or if I get to sketch that on the side, this will be the shape of the block we're going to start our cut with to find the final shape of the part. 200 by 200 by 20 millimeter thickness. So the cutting tool will do the job, remove the total material until we're going to have the final shape desired. How to hold such shape on the milling machine? On the milling machine, we have a table. The table usually going to have slots. These slots have a T shape. So within this slot, I can slide bolts. These bolts can be used either to hold the part directly if it does have a holes, or I can use these holes and the bolts to use a clamps. A clamps is a device that holding the part from the side while I do the machining. The problem with the clamps that we cannot do the face milling for the whole area if I can't use the clamp. What will be the other method to hold the parts if it's going to be a cubical shape? We use a device called the vise. Okay, now this is the work part. I'm going to use the vise to hold it from the sides. Then I can do the whole machining at the top until I'm going to make the holes and then remove the vise and use the bolts and the nuts to hold the part on the table. I can show you some photos of that later, but the most important thing now is to come out on how to remove the material to have the final shape. The first thing I'm going to do is I'm going to cut the hexagonal shape in the middle. As we learned earlier, to find the points that I'm going to do my cutting around is do the offsetting. My cutting tool here is 12 millimeter diameter or 6 millimeter in radius. So I'm going to sketch a line which is going to be offset from each side by 6 millimeters. You can see obviously that these lines are going to be intersecting with each other on the axis of the hexagonal shape. This will be one cut. Now, offset this line by another 6 millimeters. And once again, just remember that we always need to extend these lines. So they're going to have some intersections. Okay, another extension by 6 millimeter. Now you can see that I always choose 6 millimeter as the offset. This is for two things. First, I try to do some standardization for my cut. So always going to have the depth of the cut to be 6 millimeters. Also, when I mention the depth of the cut, because I don't want to put an extra forces on the cutting tool when it's going to do the cut. So basically what we are going to have here, it's not only going to be face milling, but it's going to be a profile cuts continuously. Every time we're going to get closer, 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 until we're going to have hexagonal shape to be left in the middle. Now, I'm not going to stop until these lines is going to be moving outside the work part. So you can see that I did that, and obviously I'm going to need another cut at the outside to remove this part till here. Okay, so I just keep doing that. And this, of course, going to give me the points, again, to move in between by having these intersection points. I know we're going to have too many, but this will be a healthy thing. Doesn't matter. The code is going to be the same. The only thing we're going to do is we're going to do something like the caning. I'm going to write down 6 lines, then copy paste these lines. I'm only going to change the coordinations. Okay, so we cut the outer one first, the inner, the inner, the inner, until again to have this part. Now there's another challenge we have in this work part. When I said that the thickness is going to be 15 millimeter, we have to remember that it's not recommended to cut 5 millimeter in single shot, because this may damage my cutting tool. And also is going to give me a bad surface roughness. So it's always recommended if you're going to have something about 5 millimeters, I can cut it to 3.5 millimeter first as rough cutness, and 1.5 millimeter later as a finish cutting, because 1.5 millimeter is going to be the maximum depth of cut I can use for the finish cutting. If it's going to be lower, it's going to be better. So if it was me and I need to cut 5 millimeters, I will do it as 2, 2, and 1. 2 times 2 rough cutting, and 1 is going to be in finish cutting. I think that we talked about this one earlier in the manufacturing subject. I'm going to repeat that once again. In the case of you doing the rough cutting, the depth of cut is going to be high. The RPM value is going to be low. And the movement of the cutting is going to be high, or what we call the feed rate. So the S is going to be low, the F is going to be high, and the depth of the cut, or the Z value in negative, is going to be high, maximum 2. And when I'm going to do the finish cutting, I'm going to reduce the depth of the cut to 1 millimeter, for example. RPM value will be increasing by 150 degree. And finally, the feed rate is going to be slower. That's obvious. If I'm going to bring a knife and try to peel the apple very fast, I'm not going to have a good finishing. Well, this is just an example. Okay, so now we're going to move to the Excel sheet and we're going to describe the process of the cutting on it. I already made these lines. We're going to remove them and bring them back to here. So I think this will be my first cut. This will be my second cut. And this will be my third cut. Okay, so as you can see here, and I'm going to take this one out. Now, this is my work part. I use these blue things, which is going to be the vices, okay, to hold the part from the side. The point in the middle, the blue one, is the datum point, the 0, point. This will help me a lot because I get to only need to find the points in one of the quarters, and then I will find the points on the other quarters. And I think that you all remember the basics of the quarters of the circle. And I'm going to repeat that once again. Okay, so we held the part, and we are going to schedule lines to cut this hexagonal shape from the blue square here to have the hexagonal shape at the thickness of the 5 millimeters. So we will start first with the first line. We said that the offset here is going to be 6 millimeter. I can choose a bigger cutting tool so I can remove the material at higher rate. Something like if I would like to paint a color a whole paper using this pen, which is have a small ball pen, it's going to take me about 1 hour. If I'm going to use a marker, it's going to be done in 5 minutes because the marker is wider. So the same thing here, you can see if I'm going to have this cutting tool diameter or that cutting tool diameter, this one is going to remove the material at higher rate. What did one I choose? I think I choose, let's say I choose this one. It's going to be bigger diameter. Let's say it's going to be 20. So the offset is going to be 10 millimeter. Sketching my first line. Sketching my second offset. And my third offset. You can see that each offset is going to be offsetted from the one previous. It's not going to be from the origin. And you can see that I'm going to still have these areas. uncovered. So I can go with multiple lines like that, just to remove them. So what's happening is that my cutting tool will come from the space, come to that point, for example, and do my first cut. 1, going to here, 2, 3, 4, 5. Now I just cleaned the corners. Then I will get inside to this center. Let me try to do something else. I will cut this one. Okay. Now I'm coming to here. Let's get inside. Then again to move as normal. 1, 2, 3, 4, 5, 6. And get inside and do it again. 1, 2, 3, 4, 5, 6. Get again and cut the hexagonal shape. And 6 movements. Now remember that what I cut was the depth of 2 millimeters. That means I will go back once again to here and cut the lines around, then cut to another 2 millimeters. You may make the Z to be -4 and do the second cut, third cut, and so on. Then again to repeat once again and the final time for the finished cut of the Z equal to -5. Now, before I get to write down the code for the first step, we're going to find the points for the intersection points. And I'm going to show you how simple it's going to be. Okay, now that's my hexagonal shape. I'm going to give this back to Kmart. I didn't like it. Anyway, so you can see that what we have is 4 quarters. So if this one is going to be the X and that was going to be the Y, this will be negative X, of course, and this will be negative Y. That means the sign for the X and the Y here is going to be positive X and positive Y. That's basic. This side, we're going to have negative X and positive Y. Here we're going to have both are going to be negative X and negative Y. And in this quarter, we're going to have negative Y, but positive X. Now, that means if the points are going to have, for example, here, it's going to, one first intersection is going to be here. If this one is going to be just an example, well, actually, I can of course find what the distance from here to here, because this is 45 degree. Okay, this is 45 degree. Just let me check. That's going to be 45 degree. I'm not sure it's going to be, yeah. Anyway, it's going to be a 45 degree. And then the number of the angles we have for the hexagonal shape is going to be, rectangular shape is going to be 360 degree, 180 degree. And that's mean, oh yeah, so this one is going to be 60 degree, 60, 60, and 60 degree. Yep, now we know that this angle is 60 degree. We can calculate the chord of the triangle, and then I can find what will be this distance. So I can find this location. Just remember that this point is going to be offset by the radius of your cutting tool. So I can find this point as the X and the Y. Whatever I'm going to find here, I only going to change the sign and distribute around the work part. For this one, it's going to be very simple because it's going to have 0 for the Y and have value for the X, which is going to be equal to that length. The same thing here. We're going to have 0 for the y, and we have value for the x only. All the other rest, once again, just find the points on one side, and it's going to be the same coordination everywhere, but the sign is going to be different according to what we have here. We can later add another 6 millimeter for the distance and the x and the y, and distribute the points around the hexagonal offset until we're going to finish the whole thing. So it's quite simple. You got that point? Guys, you got this point, or do I have to repeat it? We're still with the mathematics, actually. We didn't go to something with the mechanical engineering. Good.
All good?
All good. Okay. So it's a straight line. That's mean what we are going to do is just go to one of the points and start to write down G01, 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 X, Y is going to be changed. That's it. So I'm going to write down my first line, my first code, which is going to remove a layer that's equal to 2 millimeter thickness and to remove the material around the hexagonal shape. This will be my first code. Once again, well, if I'm going to change the color of this one, I can say that is going to be the red one, for example. I have to do it line by line. So I don't know why I mentioned the red line, because actually I should start from the outside one. Anyway, so we're going to write down the code. Let's say that I'm going to give the code that the outer one, the third hexagonal dashed line, is going to be the points with the also point 1, 2, 3. So I'm going to have x1, x2, x3, and so on. Okay, so I'm going to take this one to the side. And okay, can I show the camera and the parts next to each other? Yeah, I think I can do it. Yep. Okay, so what I'm going to do first is I'm going to come to this point, to that point, here, here, and so on. I'm going to cut to the side first. Or maybe we can leave this one to later. I'm going to start cutting these points. So once again, this what I'm going to call it as the x1, y1. x1, y1. This one is going to be x2, y2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So point number 1, have x1, y1, x2, y2, x3, y3, x4, y4, and later by yourself, put that on the paper, or even if you would like to sketch it by another way, you can find what will be the equivalent location for that. So the first thing I'm going to do is I'm going to say, of course, I need to define that G94 and G21 and M06. Use the tool number 2. I choose the tool number 2 because this will be a larger one. Just put that the tool number 2. Tool 2. Let's say it's going to be 20 millimeter. Just remember that this sign, that's going to mean that the this part of the code not going to be written. M03, again to turn on the spindle at the speed of, this will be rough cutting, so it should be turning slow. I will put at 800 RPM. I don't have to mention the unit because it's defined already as RPM. And now we'll go with the Now, of course, I need to put the numbering. This will be N10 and 20 and 30 and 40 and 40. G00, go to the X1, Y1, Z 10 millimeters. Because I can work on this advantage. It doesn't matter with me. Now, this will be my first step. My cutting tool now is rotating at this position, at the height of 10 millimeters. Now, I would like to go in depth by 2 millimeter thickness depth. So I will write down the N50 is equal G01. The X and the Y not changing. The Z is going to be equal to -2. Now it's going to be a good idea to decide the feed rate, which is going to be something around 100 millimeter per minute. Now, my cutting tool is in this position, but it's inserted inside the part by 2 millimeter thickness. Yes, Lance.
X1 and Y1, wouldn't that, if our datum's in the middle, wouldn't that make it near the datum?
Sorry, just repeat that. I was on low microphone. Yeah.
If X1 is, if X and Y are 1, wouldn't that make it near the datum?
No. Datum is 0, 0.
Oh, so wouldn't it be at the top and the center then?
No, when I gave 1 and 2, this is just simple because this is point number 1.
Oh, okay.
Yep. So sorry for that. I should repeat that more specifically. So we will call, well, I'm doing that just for simplicity because I don't want to put numbers here now. This point number 1, so it's going to have X1 and Y1. This is point number 2, so it's going to have X2, Y2, and so on.
Cool. Thank you.
Thank you very much. Okay, as I told you, you can find the numbers because I don't want to spend some time on calculating that now. Maybe I have an old video, I can share it with you, and it's going to help you on how to do it. Okay, so once again, we are going to move the cutting tool center from this point to the point number 2. So obviously, it's going to be G01 and 60, G01 not going to be changed. We are going to write down here that this is X2 and Y2. And of course, once again, when you're going to write down the code, you should put a numbers instead of the, oh, maybe I should do it smaller, right? This will be the correct way. Anyway, I'll do this one later. And the feed rate will remain the same. No, actually, I can make it faster because this will be a rough cutting. So it's going to be 240, for example. And of course, the operation will be continue, the X3, Y3, the X4. So as you can see, it's going to be quite simple. X4, Y4, until I'm going to go back to the point number 1, but in that case is going to be called the point number 6. The same point is going to be the point number 6. Why? Because it was number 1, but 2, 3, 4, 5, 6. Oh, sorry, it's going to be number 7. So we continue with that until we're going to have the X7, Y7, which actually again to have the same coordination of the point number 1. But because the sequence is going to be number 7 in that case. Now, I just finished cleaning the outside hexagonal shape, and now I only need to push it inside here. The same depth, nothing will be changed. So I miscounting here, you can count later. So it will remain G01. I will go to the X8, Y8. Again, it's going to be 8. So this will be 9, 10, 11, 12, 13, and 14. So we continue going back, going around until we're going to have the X14, Y14, which is once again sharing the same coordination of the point number 8. Then go to inside. Now we're going to be in contact with the final hexagonal shape we would like to have. So we're going to go G01, the X15, and Y15. Again, 15, 16, 17, 18, 19, 20, and 21. So until we're going to have the X21, Y21. Now we start to have the hexagonal shape, the final hexagonal shape in the middle is shown to me. I can see it, but has 4/10 of the total depth I would like to have it to. Writing down the code once again is going to be a very longer process. The best thing to do is I'm going to copy everything from here to down here. I will copy everything. The only thing I'm going to change is going to be the Z here is going to be -4. Copy and paste because the same points, exactly the same points. I was going to go to a lower depth and continue cutting around the hexagonal shape until we're going to have the depth to be down to 4 millimeter around the hexagonal shape. Copy and paste. What will be the final depth we're going to have now? How much we're going to change the Z to? Is that
Okay, -4.
-5. Because the first one, well, I'm going to call this one, I'm sorry, from here. Copy and paste here. Change Z to -4 first. Now I'm still doing the roughing. Then paste again here. Change Z to -5. But this is not going to be enough because when I'm going to change the Z to -5, I need to put paste. Then before that, change the S to, which is spindle speed, to 1,500. And the feed rate is going to be to 100. Now I'm slowing down the feed rate, increasing the spindle speed. So again to have, exactly Nicholas, again to have a good finish cutting for the last 1 millimeter. Okay, now you can see that this number is accumulating. It's not going to be one step by step. So because we reference it from the top surface, the original top surface. So when I'm going to go the first 2 millimeter, I will say -2. When I'm going to go another 2 millimeters, is going to be -4. When I'm going to go an extra 1 millimeter, is going to be -5. Okay, so these are the code. You can see that this will be quite long. So we can simply do that. We have another code, which is, I think, the M34. I forgot the name of the code thing, G34 or something. We called for the caning process. So in the caning code, you just mention how many times you need to repeat the following block sequence. For how many times and what are the depth? So you will say that I would like to repeat the following steps for 3 times as Z equal to -2, Z equal to -4, and Z equal to -1. So the machine, which is a computer in the machine, will understand that we need to cut it in 3 steps, 2 rough and 1 finishing. We can learn this one later as we go. Okay, usually this is not preferable to be learned in the manual handwritten. Okay, now I think this will be the hardest thing. Now tell me about how we can cut a circle. The circle is 25 millimeter diameter. My cutting tools are, we have the 12 millimeter diameter, and we have the 20 millimeter diameter. But the pocket in the middle has 25 millimeter diameter. That means it's not going to be a simple drilling operation, but that will be something I'm going to teach you. It's going to be very important on how to make a pocketing by using a larger cutting tool. Now I will sketch just the circle in the middle individually. The center of the circle is the datum point, which is the 0, 0. If I'm going to put my cutting tool in the middle, it is 12 millimeter diameter. That's mean I also was going to have on the sides, this one is 12, we're going to have something about 6.5 on each direction. Need to be removed. So how we can solve this problem? When I'm going to go to the middle, drill a hole, then I'm going to move to either side. For example, I'm going to move to here, leave 6 millimeter from the side. Okay, I'm going to have new center. So my cutting tool is going to be in this location. Sorry, it's going to be in this location. And then I'm going to take it in a full rotation and bring it to here. So in this way is going to clean the place. Well, I think I need to show you that by using, yeah, we can do it here. Where's the small cutting tool? So we can bring the cutting tool to the middle, drill the hole, which is going to be the 12 millimeters. Then we push it to the side, then make a full turn for the cutting tool, and then it's going to clean the place. You got this point, or still need some explanation? Because I can do some explanation. Let's imagine that this is the pocket. This is my cutting tool. It will come to the middle first, drill a hole. Then it will be go to the side. Then with the G02, it will move to this position. And then it's going to move to another position, finishing the cleaning. Easy?
Yeah, makes sense.
Makes sense. So again, to do it here, and I would like to ask you to write down the code yourself. G00 to this position at the height of 10 millimeter. Then G01 to the depth of whatever the hole is. Let's say it's going to, if the hole is not 2D, we can do it in single shot. Let me check what will be the depth here. Yes, it's 5 millimeters. So we can do it in single step. Okay, so we get inside. If you're going to, if you would like to do it in 2 steps, this will be okay. But once again, we are going to write the code once, and then we're going to copy it and paste it, just changes that value. So we go to the Z equal to, let's say, -5. And now we are close to it. Then we go to the G01 to the side. Now, just to be sure that the side of the cutting tool here is going to be attached to the circumference of the work part. That means the circle, which is denoted as a blue circle in this diagram, this circle should be offset from the black circle to the inside by 5 millimeters. Now, if the diameter of the circle, the black one, is 25 millimeters, what will be the diameter of the blue circle?
Sorry, is the diameter of the blue circle the diameter of the tool?
No, it's not going to be the diameter of the tool. Okay, now we said that this side is offset by 6 millimeter. This side is offset by 6 millimeter. So we have a 12. So the circumference, the diameter of the blue circle is going to be 13 millimeters. So it's just 1 millimeter only larger than the diameter of the cutting tool. Okay, so you subtract when you do the circle interference, circle cut from inside, you subtract. You always subtract. If you're going to confuse with that, use the radius. Don't use the diameter. Use the radius. So the radius of the inner circle, if its diameter is 25 as written here, that means the radius is 12.5. So the inner one is going to be offset by the radius of the cutting tool, which is 6. That means the radius of the inner one is going to be the 12.5 minus 6, which is going to make it 6.5. Just think about it that way. All good?
Yeah, thank you.
Great. Okay, so now that means this one was a 0, 0, of course. When I'm going to push it to the side, I will say that the G01, the Y is going to be 0, but the X is going to be equal to 6.5. Then I'm going to make a full circle. Now we have a problem here. You remember, if I would like to cut, do a movement in an arc cutting, I can simply say G02, going to that point where the X is equal to minus 6.5, the Y is equal to 0, 0. Okay, and the R we had here was equal to 6.5. And I can write down the feed rate, anything as 150, for example. And then I will write down G02. I would like to cut a full circle instead of a crescent. So what I'm going to do is go to the X is equal to 6.5, Y is equal to 0, 0, and the R is equal to 6.5. And no need to write down the feed rate. Now, I can actually combine these two lines instead of taking from this point to that point, then from this point back to this point. Now, why I'm doing that? Because if I'm using the R, I cannot make a full rotation circle. It will stop at 1 degree, and this is one of the problem we have with the R code. Okay, I mean this R code. So it's not going to complete 360 degree. Well, it will stop something between 355 to 359. I was usually showing that to the student in the lab and just before the lockdown. Unfortunately, we couldn't do it last year. I mean last semester. So we can finish that and do it as one cut by. I'll write down the code, coming to the center, going to the side, and cut, clean the pocket. So G00, X equal to 0, Y is equal to 0, the Z is equal to 10. G01, X and Y not changing, Z is equal to, let's say, minus 5. And usually this is not recommended. Feed rate is going to be 100 millimeters per minute. Then G01 going to the X is equal to 6.5. Y is not changing. Z is not changing. So I just push the cutting tool to the side. This point is 6.5x and 0 for the y. Then I'm going to do the full turning, G02. Now, I will go to the x is equal to 6.5. Yeah, I'm not wrong. The y is equal to 0, 0. Now, once again, I'm still doing the correct thing. Now, in that case, I cannot write the r. And instead of that, I'll write down that the I is equal to 0, 0, and the j is equal to 0, 0. The machine will understand that it needs to go around the datum point in a full circle. It will calculate the radius, and it's going to be 6.5. So the cutting tool will move and go back to the same position. Very simple. Okay. And now if I would like to do it in steps, instead of not having the -5 here, we're going to do it as -2.5. Then what I'm going to do is at the same position here, the next step is going to go down, make a full circle, then go back to the center. And then I'm going to clean the full pocket as a cylindrical hole. Good. We still have another 5 minutes to go. And during these 5 minutes, I'm going to be quite fast just to show you how to make the C cut. And this will be actually something like your homework. So now G00 going to at the top of this position. G01 get inside. G02, sorry, if I'm here, G03 and find the location of that point. So this will be the movement that's going from here to here with the radius, which is equal to 35 millimeters. That's it, very easy. So to cut the C shape, I will consider that point to be 35 multiplied by 45. 35. Let's see. Yeah, it's going to be 45. Yeah, I don't have to. 45 multiplied by cosine of by 0.707. What will be 35 multiplied by 0.707? Please help me with that. I'm not a calculator. Good thing, and as an old man, I can remember what the sine of the 45. Yep. So what will be the 35 multiplied by 0.707?
24.
24. Let's say 25. Let's say 25. Or 24.5. Okay. So yep. So in cutting the C shape, I need to use another paper because actually as I told you, I didn't like this new holder. So yep. Now the C shape have 270 degree. That's mean the distance between the things is going to be something about 90 degree. Yeah. So this point, according to the calculation, the x, because we know that this one is 35 and this one is 45 degree, so we can find the x and the y as 24 and 24.5, 24.5, 24.5. So this point is going to have the coordination of 24.5 and 24.5. The location of the point here, the y is going to be changed as negative. So the 24.5 and negative 24.5. Okay, so the only thing we need to do is bring the cutting tool to this location, drill the hole, and then make the G03 in that case to this position and leave. So G00, X 24.5, the Y is 24.5, and the Z once again is going to be 10 millimeters. G01 the Z to, let's say, -5. Okay, and the feed rate need to be specified. And then we are going to go with G03. And now we identify this point. The X is going to remain the same, but it's going to be good to write it down. So we're not going to confuse the machine. -24.5. And the radius is equal to the 35. Or I can write down that the I is equal to 0 and the J is equal to 0. Now, this is actually one of the good thing when you are going to use the datum point as the center point, and everything, all the I and the J's will be referenced as 0 and 0 because it's in the middle. Okay, so by that, what we've done is we brought the cutting tool to here, make a drill, and then we G03 to come to this position. Then we need to leave the work part by G00. Going to the Z is equal to 10 millimeters. So we left this thing. Okay, now anyone have an idea on how to drill the holes, these small holes?
You just move over the top of them with G00 and then
to the final depth, which is -15, and then go up. You go to the next location, G01 to the -15 Z, and you go up. And you keep doing that for all the 6 points. Now, it's a very common application and, well, actually a procedure. When we do the drilling, we're always going in the clockwise direction. That means if I'm going to drill this hole first, this will be the next, the third, the fourth, the fifth, and the sixth. We never try to go, well, actually, if you're going to counterclockwise, it's going to be okay, but we will never try to do it as that because this traveling distance will be wasting of time. So we always try to do it in a sequence, either in the clockwise direction or counterclockwise direction. And of course, the last thing we need to do is we're cutting the circle. And this shouldn't be something hard because we learned how to do it earlier in the profile cutting. But just remember that you can see that the thickness here is quite high. And we have the vise on the side. If I have the vise on this side, I will not going to be able to cut around the work part. So give me a suggestion. How can I cut the cube shape? Sorry, well, it's still square shape. How can I cut the square shape into a cylindrical shape? How can I hold it? Now I have the vise, but I need to cut in a way that I'm going to avoid cutting the vise at the same time. So what will be the best thing to be done? So I'm not going to hit the vise. Nope, lathe is going to be quite hard. Now it's very easy, just remove the vise. Take the vise away. No, look, take the vise away. Okay, now remember that we just drilled the holes. So I can use bolts and nuts, at least 2 of them. Now the black is not cutting tool now, it's bolt. Okay, fixed on the table. Now the cutting tool can move freely around. Got that? Easy. Okay, now what this is more important than anything else. Think as a mechanical engineer. I just keep saying that for all the students we have in at the UTS since 2011. Now, the mechanical engineers are something like the idiots. Okay, we are idiot of the engineers because everything you can see around you had the principle of the mechanical engineers. Even the civil engineers were not going to survive without us. They had maximum to build two-story building, and then with the mechanical engineers, they went to the high-rise building. Imagine high-rise building without structure that we did. Imagine a high-rise building without elevators. Going to the space, the cars around you, all the furnitures, all the computers. It's not just electronics, because the electronics is just something in the board that you, as a mechanical engineer, involved in its manufacturing. We move the words, we destroy the word by the solution. We're going to say the word. So things logically, that's what we need from you to be a successful mechanical engineer. I cannot say that I'm successful mechanical engineer, but I try to be a successful mechanical engineer by thinking as a mechanical engineer. Okay, so this will be the most important thing in our today lesson. This will be your something like a homework. I would like you to, I'm going to send the assignment paper for the Western Sydney Union to you, everyone. I'm going to share it on both the Canvas, sorry, not Canvas, the Teams. I'm going to share it on for the student on the using the Zoom. I'm going to share it on LinkedIn, and I would like you to practice that. Write down the code, put it on paper. Sorry, on Word document. Copy and paste on the simulator, and try to show me something next week. Okay. Well, let's say by Thursday session. So after we are going to finish the G code for the turning, I would like to show some. I would like to see some example for the operation of the cutting of this part. Okay, thank you for today coming, and I hope that you enjoyed today's session. Maybe it was boring, but at least I hope that we learned something about the third dimensions. Yes, Lance, go ahead.
I just had a question. Do you have a document on how to decide what the feed rate and the speed are?
I can send you some links.
Awesome. Thank you.
I will send you some links because actually we have something called the engineering handbook, the machining handbook, which give you all the combination. But lately we couldn't find it on the UTS library, so we go to some of the calculator available online, which can help you a lot. So I'm going to share that with you soon.
Awesome. Thanks so much.
Thank you very much. Thank you, everyone. I hope that you enjoyed the rest of the day, and take care, be safe, and see you later.
Thanks.
Thank you.
Thank you. Bye.